Hi everyone! Today we're going to discuss about method of members. Force members in general are non-actual members that are not simply in tension or compression. Members of this kind have shear forces perpendicular to the member and subjected to bending loads. Frames are pin-connected structures with force members. And to analyze a frame, we can disconnect the force members from the structure and draw the free body diagram of each member. This approach is called the method of members. In this method, three equilibrium equations can be written, and these are the summation of forces on the x-axis, the summation of forces on the y-axis, and the summation of moment, which are all equal to 0. So here's a sample problem to have a deeper understanding on the method of members.
So good day everyone. Let's discuss for today method of members. So our problem is to determine the reaction of B in member CD. So member AB and member CD are connected by a pin at point B. The first thing to remember or the first thing to consider in solving method of members is to draw a free body diagram of each members. So let's start at member AB. Member AB. So there's a 200-pound force, and in the figure there's a hinge. So as discussed earlier, hinge has horizontal and vertical force acting upon it. So AX, the horizontal force, and AY, the vertical force. So at B, point B, we have the BY, or the vertical force, and the BX, the horizontal force. So I assumed the direction that the direction of the forces is in this way. So you can also assume directions because it will not affect the final answer but the direction. So at let's have the second member, the CD. So it's just a line or member. So we have a 300-pound at point C, and at B we have the horizontal force Bx and the vertical force By. So again, there's a hinge in the figure, so that's the vertical and the horizontal forces. So again, I assumed the direction of the forces. So for the solution, um, it's stated in the problem that we should get the reaction of B. So we're going to find the Bx and the By component. So let's start at member CD. So at member CD, we should get the summation of moment at point D equal to 0 because it's in equilibrium or stationary. And for starters, so let's have bx because the rotation is in clockwise direction and the distance is 4 feet, and 300 positive again because clockwise direction, and the distance according to the figure or the illustration is 6 feet. The force By is disregarded because it will pass through the point D, so it is equal to 0. So we can get Bx as negative 450 pounds. And so let's have negative 40 as is. So at member AB, again, let's have, because we have the value of bx, we are going to find the value of by. So let's have the summation of moment at A equal to 0 again because it's stationary. So let's have 200 force. So the 200 is clockwise, so it's positive, and the distance is 2/5. And negative by, because the direction of the by is counterclockwise, and the distance is 4. Again, and also the bx is counterclockwise, so it's negative, and the distance is 4 feet, equal to 0. So let's have this 400 minus by 4, and we have the value of bx as negative 450, 4 equal to 0. So we get the value of by as 550 pounds. So this is at member AB. So the problem states that we should get the reaction of B in member CD. So of course our reference is the member CD. So the final answer is BX 450. So CD 450 to the left. We change the direction, so the value will yield to a positive. So by is, so we get the by at member AB, and it is stated that we use CD as a reference. So CD by is 550 pounds, and direction is downward. This is the final answer. So for the answer, or for the